Number 5, we're asked to sketch a graph of our function, our piecewise function, and then determine the limits, right side, left side, and overall. With a piecewise function, basically we're taking two functions and piecing them together. We're making a new function out of two or sometimes more than two functions. Here we're going to have part of the function look like a line, the other part is going to look like a parabola. So let's look at the left half first. This is happening when x is less than or equal to 2. So basically, kind of imagine a invisible line here at x equals 2. The left side is going to be a line, right side is going to be a parabola. Sometimes in these piecewise functions, the graphs connect. The two halves connect at a point, sometimes they don't. Well, let's start off by looking at where this line is going to end, because it happens when x is less than or equal to 2. So I'm going to substitute 2 in for x into this portion of our function, and we get 1. Since this is a less than or equal to sign, this is a point that's included in the graph. We're going to have a solid dot at 2, 1. Then we're going to graph the line to the left of that point. So we have a y-intercept of -3. So we'll go on our y-axis at -3. Slope is 2, up 2 over 1, up 2 over 1. But we're not going to go any further than that. We're just going to start here and go back this way. So that's the left-hand side of our graph. So actually, we could go over here and do part B already. Part B asks us to find the limit of this function as x approaches 2 from the left. Well, this is the left half of the graph. So if we're looking at this from the left, side here, as we get closer and closer to 2, our y value is approaching 1. Alright, so our left-hand limit is 1. Now, so look at the right side, we're going to graph the right side of the graph. So we're going to do the same thing. We're going to start off by putting 2 in, kind of see where our parabola starts. If we put 2 in here, we get 1 squared, which is 1, plus 1, which gives us 2. So we're going to have a point at 2, 2, but since this is just greater than, we're going to have an open circle at that point. It's not included in the graph, so kind of like a little hole there. But we do have a point down here with an x value of 2. Now we need to graph the parabola to the right of this. This is set up in vertex form, so we can look at this and figure out where the vertex is shifted. Normally, y equals x squared has a vertex at 0, 0. But by subtracting 3, adding 1, it shifts that vertex in the whole graph. The -3 is going to shift that vertex to the right 3. And the +1 will move the graph up 1. So its vertex will now be at 3, 1. And we know that parabolas are symmetric about the axis of symmetry, which goes right through that vertex. It's basically a mirror image on either side. So if we know there's a point here on the graph, then there's got to be a point on this other side of that axis, same distance away. So basically, here we go up 1 to the left 1. To get our other point, we go up 1 to the right 1. And we can find other points. We can just plug in 5 in here. 5 minus 3 squared plus 1. We end up getting 5. So that's enough. We can go ahead and draw our parabola portion of the graph. And now we can look at our limit from the left side. I'm sorry, from the right side. Right of 2. So as we look at this limit, as we get closer and closer to the next value of 2, the y value is getting closer and closer to 2. Since these one-sided limits are not the same, that means our overall limit does not exist.